You ever look at a map of the world's energy and just wonder, why there? Why is so much of our planet's oil packed into a few specific places while huge parts of the world have almost none? Well, it's not random. Not at all. It's actually the result of a geological lottery that's been playing out for hundreds of millions of years. And once you understand who won and how they won, you'll never look at a map the same way again.
Okay, first, let's just get a sense of the scale here. Nearly half, a full 48%, of all the world's known oil reserves are sitting in the Middle East. I mean, think about that. That is an absolutely staggering concentration of a critical resource in just one neighborhood of the planet. It's a single fact that has shaped, well, pretty much the last 100 years of history. And it immediately begs the question,
why? Why this incredible imbalance? This isn't just a question about economics or politics. At its heart, it's a deep, deep geological mystery. And to solve it, we need to travel back in time, and I mean way, way back, to understand the incredibly specific, almost impossible recipe for making oil.
Right, so think of it like a cosmic cooking show. The main ingredients are ancient life, and the oven is the Earth's crust itself. But here's the thing. This isn't some 30-minute meal you just whip up. No, this is a recipe that takes eons, literally hundreds of millions of years, to get just right.
So what even is oil? Well, it all starts with life, and not dinosaurs like we often imagine. We're talking about trillions upon trillions of tiny microscopic organisms, plankton and algae, that lived in ancient oceans. Now here's the crucial first step. When they die, they have to get buried in an environment with very little oxygen. That part is absolutely key, because otherwise they just decompose and poof, they're gone.
And what a journey it is. After these tiny critters die and settle on the seafloor, they get buried under layer after layer of sediment. Over millions of years, all that pressure squishes this organic goo into a waxy substance called kerogen. Then, as it gets buried even deeper, the intense heat and pressure start to do their work. They literally crack that kerogen into the liquid hydrocarbons we know as crude oil.
But here is where the recipe gets incredibly precise. The cooking temperature has to be perfect. Geologists actually call it the oil window, a super narrow temperature band. If it's too cold, the kerogen just sits there and never transforms. But if it gets too hot, it overcooks and becomes natural gas instead. This one little detail means that vast amounts of buried organic matter all over the world just never had a chance to become oil.
But okay, even getting the temperature just right isn't enough. Not even close. You also need the right, let's call it, kitchen equipment. For a working petroleum system to exist, you need 4 essential geological components to all be in the right place at the right time.
And this is the whole shebang, the 4-part system that has to work perfectly. First, you need the source rock. That's the kitchen where the oil is cooked. Then, that oil has to migrate into a porous reservoir rock. Think of it like a giant underground sponge that soaks it all up. Above that, you absolutely must have a cap rock, which is a layer that's impossible for oil to get through. It's the lid on the pot. And finally, you need a trap. A special geological shape that gathers all that migrating oil into one big, concentrated pool. And get this, if any one of these 4 things fails, you get nothing. 0. The whole batch is ruined.
So where on earth did all these ingredients come together so perfectly and on such a massive scale? Well, that brings us right back to the Middle East. It's here that this billion-year recipe was perfected, thanks to an ancient body of water that no longer exists, the Tethys Ocean.
And, calling it a miracle isn't an exaggeration. Geologists have identified at least 11 distinct factors that all had to line up perfectly for this to happen. The odds of this combination occurring are just astronomically low, which is exactly why this region is so unique. So what was so special about the Tethys? Well, it was a perfect storm. First, it was a warm, shallow sea just exploding with life, a biological frenzy creating an unbelievable amount of source material. Then, things stayed nice and stable for a long time, allowing sediment to pile up, sometimes up to 12,000 meters thick, burying that material deep in the oil window. And then, when tectonic plates finally collided, they squeezed and folded these layers, creating enormous, perfect whaleback traps for the oil. To top it all off, huge salt layers formed a perfect regional seal. The sequence of events was just flawless.
But here's the thing. The Middle East wasn't the only winner of the geological lottery. Other regions around the world have their own massive reserves. They were just formed by unique variations on that same fundamental recipe.
So let's do a quick comparison.
The Middle East is defined by these massive marine carbonate rocks from the age of dinosaurs, the Jurassic and Cretaceous periods. But then you look at North America, and it's a totally different story. Here, we're often dealing with much older Paleozoic shales and different kinds of rock altogether.
For example, in Texas, you've got the Permian Basin. It was formed by a continental collision that created basins perfect for generating the tight oil that's become so famous today. Then you go way north to Canada's Athabasca oil sands, and it's a completely different deal. There, conventional oil migrated up towards the surface, where microbes essentially ate all the lighter parts, leaving behind that super heavy, thick bitumen.
Now check out this number, 1 million square kilometers. That is the mind-boggling size of the single ancient sea that created Russia's Bazhenov Formation. This one source rock is responsible for over 80% of West Siberia's colossal oil reserves. The scale is it's almost impossible to comprehend.
And in Nigeria, we see yet another clever variation, this time on the trap ingredient. Here, the sheer weight of river sediment piling up caused the rock layers to slump and fault under gravity, creating thousands of smaller individual traps. It's a totally different structure from the giant folded traps of the Middle East.
Okay, so let's pull all this together. This table really shows the unique geological signature of each oil titan. Just look at the trap types. They're different in every single place. The Middle East has its giant anticline folds. The US has more complex structural traps. Russia has something called cliniforms. And Nigeria has its unique growth faults. It's the same fundamental recipe, but each region has its own completely distinct kitchen.
So, after this journey through deep time and all across the globe, what's the big takeaway? How should we really be looking at a map of oil reserves now?
The truth is, the energy map of our world isn't really a map of today. It's a ghost. It's the faint echo of lost oceans, of colliding continents, and of ancient climates that, through sheer cosmic chance, created these incredible and totally finite deposits of concentrated energy.
And that leaves us with one final and pretty crucial thought. It took hundreds of millions of years of impossible luck for this geological lottery to pay out. And we are consuming that prize in the geological blink of an eye. So the ultimate question isn't just why the oil is where it is. It's what are we going to do when this once-in-a-planet's-lifetime prize finally runs out?